Okay, so this is an interesting problem. In fact, we're about to tonight or tomorrow morning about to start a section in your calculus book that relates to this problem, even though this is specifically by itself not a calculus problem. Is evaluate the following sum and then simplify your answer. So it's 1, the fraction 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over 4 times 5, etc. In other words, a half plus a sixth plus a 12th plus a 20th plus a 30th all the way up to 1 over 2018 times 2019.
Alright.
Okay. So, do you have the marker?
Yeah.
Nope. Jeez, I got these.
Alright.
Okay. 1 over 1 times 2, 1 over 2 times 3. Alright. How do you want to approach this one?
Well, I'm thinking we could pair these. Pair them by the even number. So, like, we can say this is 1/2 times maybe 1 plus 1/3 plus 1/4 times 1/3 plus 1/5, and then plus at the top.
Alright, well let's see what that gives you.
Well, this is going to be a half times 4/3 plus 1/4 times 8/15. So this does look like it's going to simplify. So we get
2/3
Plus.
2/15.
yeah. Plus, and then it's going to be most likely 2. What are you going to be doing? 7 times 9.
Nope.
It's just the.
What's the next pair?
Oh, it's. I don't know. It's 1 and 3, 3 and 5, 5. It's gonna be 5 and 7.
Okay.
So 35.
So it would be, let me see if that's right or not. So it would be 1/6 times 1/5 plus 1/7. Okay, so yeah, so 2 over 35. Okay. But we still have a long sum here. And you're right, it does simplify.
I think now we might be able to factor some stuff out, and then we could use the geometric sum formula afterwards.
Okay, is this a geometric series?
No, because when you get the 2s, there's a 3rd plus a 15th plus a 35th,
Yeah.
which is weird.
Yep. This one's tough. That's a good approach, though, but pairing them with their neighbors gives us another series. It does reduce it a little bit, and maybe then you compare these and whatnot, but it's still not going to get you to the end on this one. So there's a different approach. There's something else we can do here. So we have a long sum, so we gotta figure out if we can find any patterns, and we tried to find one. What else could we do to look for some patterns?
We could try to pair other numbers or other terms. I'm not sure. Because we could maybe try to pair the first and the last, but that's going to be kind of complicated.
Okay.
So,
All right.
So,
Do you have any other guesses? What's making this complicated?
well, there's no pattern between the numbers.
What else is
then we
making it
have different
complicated?
we don't have a common denominator to like add, can
Okay.
add up anything.
What else is making it complicated? What's the obvious thing making this
The
complicated?
length.
Okay.
So maybe we just start small and see if we get a pattern.
Okay.
So, just the first term is 1/2.
Yeah. So this is a good starting point on a problem, any kind of problem like this. This is complicated because you're having to add up a gigantic list of numbers. So maybe just start adding them up in the beginning and see if you see a
Alright.
pattern.
So you get 1/2, and then we have 1/2 plus 1/6. So I'm gonna leave it.
2/3.
I want to leave it unsimplified. No, let's simplify it. 2/3 and then
2/3.
4/6 maybe if we need it.
Alright.
And then it's going to be 2/3 plus. Actually, 4/6 might be the way to go. It's 4/6 plus a 1/12.
Okay.
So it's 9
9
9/12.
or 3/4.
Or 3/4. Okay.
So, figure this. It's gonna help us. 3 plus
And then
1/12 plus
yeah.
1/20th
So 15/20ths. So this is going to be 16/20ths.
or 4/5.
Yeah, this is the way to go.
Alright.
So I guess at the nth, when we evaluate n terms of this series, we get
N
over
n plus 1.
Okay.
and then this is the 2018th term.
Yep. So we get 2018 over 2019.
Pretty cool, huh?
Yeah.
So this problem was difficult because we had to add up 2018 fractions.
Yeah.
Pairing them was a good idea, definitely, and it even was sort of an idea that looked like it might help because it did simplify when you paired them.
Mhm.
Yeah.
But you still were left with something that was more than 1,000 terms long, and the terms themselves didn't seem to have a connection.
Yeah.
But reducing this problem to a slightly easier problem and adding them up shows that this is the answer. I'm gonna show you the idea here just because we're about to start talking about something called partial fractions in calculus. So when you have this and 1 over n times n plus 1, this equals 1 over n minus 1 over n plus 1. And you can see if I got a common...
Plus 1?
Yeah.
Oh, okay.
If I get a common denominator on this side, it's n times n plus 1, right? And then I have to multiply this by n plus 1, so I get n plus 1 minus n over n times n plus 1, right?
Mm-hmm.
Yep.
So this series now, here, using this idea, so I'm going to just try to give myself a little more room, 1 over n times n plus 1 equals 1 over n minus 1 over n plus 1. So this series now, here I get this term here is 1 minus a half.
Mm-hmm.
This series is plus a half minus a third. This series is plus a third minus a fourth. All the way out to plus 1 over 2018 minus 1 over 2019. And do you see what happens?
So everything inside except for the minus 2019, or minus 1 over 2019 cancels.
Yep. So you get 1 minus 1 over 2019, which is
2018 over 2019.
18 over 2019. Yeah, so it's this algebraic decomposition of these fractions that does it. But you can also see it in the pattern by doing the partial sums.
Alright.
Cool. This is a pretty fun set of problems here.
Yep.
You guys enjoy this?
Yep.
Yeah.
All right. Good job.